Hi everyone. Welcome Professor Dipankar Dasgupta, who is a distinguished lecturer for IEEE CAS, and he's gonna give a talk on AI versus AI viewpoints. This is IEEE Days of event. Okay, please welcome Professor Dipankar.
Hello, good morning, good afternoon. It depends where are you. I'm going to talk about the AI versus AI, my viewpoints, and I'm sure it will generate a lot of interest and discussions. So before I start the topic, I'd like to give two on who I am and how authoritative I am on talking about this topic. So, last 35 years, I have been researching on AI ML, and you can see inner core is my evolutionary computation, immunological computation, cellular automata, neural networks, and then next layer is the fuzzy logic, data mining, intelligent agents, and applications are a wide variety of applications, though primarily now I focus on cyber security or cyber defense, but it is all applications. My publications have 300 plus publications with about 20,000 citations, and you can see that from this chart here. And many of my research are collaborative research, multidisciplinary. So this is, and as some of the outcomes are my books, Evolutionary Algorithms in Engineering Applications with Professor Mikhailovich in 1997. And then the next is in 1998, Artificial Immune System and their applications. This opened a new area of research and applications in how immunology concept can you use as a computational technique. Then in 2008, the immunological computation book as a textbook for graduate students came in, and I'm assuming I have not seen any other new book on the field since then. So in 2017, using different approaches, I wrote again with my students this textbook, Advances in User Authentication, and which is widely used in graduate classes. I have number of patents awarded and published, submitted. Most are using different kinds of AI ML algorithms to solve problems, in particularly in cybersecurity. I'm also organizing IEEE Symposium on Computational Intelligence in Cybersecurity since 2007. It is part of the IEEE SSCI, and this will be this year. It will be in Singapore from December 4th to 7th, 2022. With that about my information, now I'm moving to my talk outline. I'm talking about AI ML algorithm and their application to start with. Then I'll move into the AI challenges, bias, and duality. Then the adversarial aspects of AI ML. Then how digital twin came in and what role the AI ML can play. Then we'll talk about ethical AI and we need regulation or some kind of guideline which need to be followed. That's one of the area I'll focus on. Now, I'd like to give a disclaimer that this presentation is a collection of information from different sources, and credits are given to the original contributors. The talk is intended for educational purpose only. So, to start with, I'm going back to the historical perspective. If you see, mathematics and statistics are underlying building blocks of all computational algorithms. There are more than 50 so-called AI ML algorithms and heuristics. Some are model-based, most are data-driven, and they rely on data quantity, quality, and reliability. So let's Learning models, they are supervised, unsupervised, semi-supervised, all different, real-time, incremental, different kinds of learning models. But the parameter tuning is one of the important things in most of this learning model that for decision making in detection, recognition, classification, and prediction tasks. Performance typically varies with the training and focus on generalization and specializations. This is in an ideal situation, but later on we'll show that some other ways people can temper and produce different results. Generative AI can create new objects from existing or new synthetic information. There is a tremendous progress on text to image and text to video generation. So all these things are possible because of increased computational power and connectivity, making the AI ML systems in large-scale real-time applications. So in the right side, I showed that different algorithms that constitutes, some of them are listed. There may be many who are not listed, just to bring it that AI/ML is not only neural network or convolution neural network. So again, technically, AI is a subset of algorithms. ML is a subset of AI. Artificial neural network is a subset of ML, and deep neural network, CNN, and many others. So AI, theoretically, AI is not equal to ML. In the past, we used to call symbolic and non-symbolic AI, and now people are largely working on machine learning, in particular, multi-layer neural network. So there are AI applications, as we see later on. Some are narrow use of AI, some are general AI. General AI use multiple combination of techniques, and that gives a more robust approach. If we look at the, again, history, AI/ML moved from pure research to application and products in last 50, 60 years. So starting from standalone expert intelligence or recommendation systems, now mobile AI agents, bots make into the global cyber ecosystem. In the past, AI/ML were used for fun, entertainment, now business, government, society, and beyond being used. But the line is becoming blurry between real and fake for human to understand, and that's become a social dilemma. Here is my point on, do AI/ML be needed or useful for all application? Probably not. Where the search space is small, that is the data set being small, or the problem is have a linear trajectory in reaching the goal or learning, and which are not multimodal or multidimensional, probably simple statistical methods can solve those. Now, again, from when I'm making, I don't consider that support vector machine or regression analysis are AI/ML techniques. Yes, they are building blocks of some AI/ML methods, but if someone claim I'm using support vector machine and that's AI, I mean, there I differ. Sensors, IoTs are being used for data collection, process using AI/ML techniques for real-world decision and actions, and that is becoming an autonomous system in most applications. So most AI/ML based systems of today and future will be cyber-enabled, putting this in an additional risk of getting compromised, manipulated, destroyed remotely much more easily than what we would like. Those need to rely on security and privacy of cyber technologies. So it is not only AI/ML system, now it is being on top of different cyber systems and connected to the wireless, and cellular, and all this have security and privacy issues. So we cannot look at the AML system as a standalone for that point of view. I'd like to highlight, and in a couple of my recent lectures, I also talk about this. If you look at Deep Blue defeated world chess champion, and that was a big success and top news that world chess champion Kasparov was defeated by Deep Blue, a computer program. Then Jeopardy, IBM Watson defeated 2 human champions in Jeopardy. So that's another supercomputer uses different algorithms to play with humans. So those successes are turning points. But here are my thoughts on those. Question is, who will win in this kind of man-machine competition? This man-machine game demonstrates that an AI machine is faster, better in winning competitions if trained with the significant amount of relevant information. If it is a well-defined game, the rules and moves and goal are well-defined. That was the situation at that time. And you can see in 2021, IBM Watson, an AI-based question answering supercomputer, played Jeopardy and demonstrated the power of AI by defeating 2 human champions. So man versus intelligent machine, the question, and there is a lot of philosophical questions come and on that competition or that challenge. I will now focus on if 2 AI algorithms or if 2 thinking intelligent machine or robots compete in playing a game such as chess, a game of card, or Jeopardy, when the environment unpredictably changes in terms of game rule, board size. Now the question, which AI algorithm will win? My prediction is it will depend on which AI technique can take correct dynamic decision based on current state, that is the board, best move, and that which can take those decisions very quickly. So it is a intelligent game. So if 2 competing AI techniques, if they are equally efficient, the game may result in draws. So that is the case in today's modern cyber or any other warfare with intelligent war fighters are fighting each other, whether it's a drone, whether it's a missile or whatever kind. So which will win will determine how much flexibility and adaptability been embedded in the system so that it can take a right decision even in a dynamic situation. AI/ML systems play dual role. In many cases, there are multiple roles it can play. And to start with, in early days in 1990s and in 2000s, there are a lot of work being done using mobile agents, intelligent agents, and all kinds of agents roaming around the internet and trying to solve different problems in searching, optimization, decision making. And Sophia and Alexa and many others are now talking to human, responding to the questions, answers. So they have the archive of information. They try to use different techniques, natural language and other to make a meaningful answer to the question. And also AI-based warfare or robots are fighting each other. There are a lot of movies also been built around this concept of good robot, bad robot, of those kind. But here again, how the AML will be used, that's the real question. Will it be benefit to the human being, or it is for other use? In continuation with the dual role, particularly in cyberspace, AIs are being used for offensive purpose and also for defensive purpose. AI-based tools are used for interruption of service, taking control, and breaches, cyber attacks, malware, advanced malware and advanced persistent threats, ransomware, all use different kinds of intelligent technique to exploit, to do phishing. All kinds of things are we'll consider the offensive AI. AI techniques are also providing defense in depth, proactive, reactive, intrusion detection system, adaptive authentication, access control, testing, and surveillance purposes. So we see that there is a wide variety of applications for using for defense, offense. Also, there are many others. So though it's a dual role, but it can play multiple roles, as we see coming. So security of AI need trustworthy AI to prevent data manipulation and froze AI. So when you are using the AI technique, because it is cyber, it also have to have its own security and privacy component so that it can be a trustworthy application. Now, wide applications of AI and ML techniques that we have seen, starting from finance, gaming, astronomy, healthcare, transportation, agricultural, education. Now, education, you can see the different modules are taught in a different way so that transfer of knowledge can be good. But at the same time, there are some AI-based techniques which help students to solve assignments. So that may not be appropriate because students are not supposed to learn. But if they give it to an AI agent which solves the problem for them, where they will learn. So there are in every aspect, you will see e-commerce, if the customer data are used for business purpose without their knowledge, that's not appropriate. That violates the privacy of the customers. So AI-based technology is rapidly changing our daily lives, impacting our business, wealth, health, and society and government. So, and if you look at the growth of the application of AIs, it is investment in applications will grow to 35.8 billion in year 2021, according to the International Data Corporation's report. And businesses are spreading in all areas, in retail, banking, service sector, smart, intelligent healthcare system, fraud detection, self-driving vehicles, among many others. And this is the market analysis by Gartner. So you can see 33% of the technologies companies are planned to invest, and majority of the investment is in AI, computer vision area, AI generated composite applications, AI augmented software development, and AI data analytics and others. So, and the amount of investments coming is continuously increasing over the last few years, and it is that investment is increasing. So this is another global picture of AI market in so estimated market value was in 2020 46.9 billion, and it will be 341.4 billion by 2027. And that's the difference you can see from big jump in 7 years. That's the prediction from global market analysis. So here are some businesses. I took only one example in this case. Nowadays, the AI-powered businesses are booming, and in particular, so you can have more customized dress with different colors. And once you select that, you can within few days the whole garment or the cloth with the proper design will arrive at your home. So and among many other things that this AI-based systems are making a big jump in business advantage. At the same time, customers are also getting significant benefit from this users. Now I will go to the challenges that AI systems are facing and will face in the future. That the AI systems can be biased. And next two slides, I'll say where the biasness comes from, how we can avoid the biasness. And there is no good algorithm which can deal with unknown, uncertain, unpredictable environment. There are guessing, there are variation to handle, but big jump problems is very difficult to solve because most of the AI/ML systems learn the pattern from the historical data, and you can some libraries of data, something have to be there from which will make an intelligent decision. So if the certain things are uncertain, then how that will be where the advanced AI algorithms will come into the picture. It may not be a single algorithm, it's a combination of things which need to be making flexible, adaptable, and just-in-time decisions. So handling adversarial ML, while the advances are going on in AI applications, these algorithms are for good people for doing good things, but it can be used in other ways. So adding noise, manipulation, deception, many things can be done to misguide these AI-based systems. And I'm going to show you that bad use of one of the AI, the generative AI, all this, how they play. So in many cases, if we deploy an automated AI decision making, it serves as judge, jury, and the executor at the same time. So if we give that much of power to the AI-based system, there must be an ethical and moral standard. Next, the question is, should we get the regulation to be implementable? Do we need a regulation to address those things? So let's go on this. AI biasness. AI bias can come from many sources and shapes, right? Historical data, unbalanced, way data was collected, processed, and presented, measurement and evaluation issues, how it was aggregated, and the behavioral and observational data. So if the data is inherently biased, the result will be also be biased. But that's from the data side. Many people don't think that even the data is good from all aspects. Algorithmic biasness can also come from by manipulation of the algorithm. Framing the problem. How you frame the problem. Many times these surveys that are being conducted, that solution is in mind, the goal is in mind, and the questions are asked according to that goal. So, and then that framing the problem becomes one of the major issues. Collecting and preparing the data, that's also data fusion techniques are there. And what kind of data fusion techniques that will be used with wide variety of heterogeneous data. Then the interpretation of data and decision manipulation, because most of the AI techniques given probabilistic answer, and how do you interpret that in what way. So need verification method that can help detect, mitigate the hidden biases within the training data, or that mitigates the bias learned by the model regardless of data quality, and provide explanation for decisions. So here is an example how the self-inflicted bias are created. So activity bias. There are a group of people interconnecting, doing survey, for example, in a web, and that survey, the website is collecting the data, and that activity also have some bias. The type of people, the thought process, gender, all kinds of things are taking part in data biasness. And then that data is sampled by the algorithm. There's maybe a sampling biasness. And then the algorithmic biasness, as I mentioned, that how you make the decisions, that also play an important role. And then after that, it goes back to the website, and that produces secondary biasness. So you can see it is not the one-shot thing. It is a cyclic in many applications of AI. Here, I'm giving two situations where the AI can reduce the market competition. Now, we know that many of the online search agents, we call it software agent, intelligent agents, may give you fewer possible options, where there are hundreds of options, but only giving fewer, whether it is a purchasing a cloth, in this case the cloth, or if it is getting the air ticket or buying a particular type of things. So if there are a lot of possibilities, but if the agent decide only to give few options, that will reduce the marketplace competition, and customers will be victimized or not get the proper service. And also there is a trend that decisions are being made by these agents. We call it collaborative multi-agent engaging in different decision making. Now, if they do the price fixing or increase the share market price arbitrarily or with certain other parameters, not the market trend, who will be responsible? Those are the things are becoming more important in using autonomous agents, using self decision-making components, because in most cases, if humans are involved in price fixing, whether it's a gas station or whether it's an antique, then there is a penalty. But if the software agents or multi-agent system do something nefarious or do something bad, question is how you determine and who will be responsible. And this is a big challenge that is coming, and there are lots of discussion going on, and I'll talk about that. This is one scenario I mentioned, and you can see other examples of biasness. Study found that Amazon's internal hiring tool that penalized female candidates. Probably the tool is not sophisticated enough, because the tool was trained with only one kind of human persons or one kind of human genders. So it will try to find that qualities of that, because most of the AI-based systems are data-driven. So the purpose is to learn from data. So if certain things are not there in the data, how that will learn? Then you have to temper it, you have to change it, and that changing may not be, also may include human biasness. So there are other applications. You can see recommendation system algorithms have discrimination and many others. Now, Amazon's face recognition system also had found to be biased on certain, identifying crimes or identifying criminals. So that's another area or a hot topic in face recognition, pattern recognition systems. Recent study shows that that a flawed AI makes robots act weirdly. And think about that robot maybe in software agent, that robot may be drone, that robot may be something else. But if they are autonomous, self-controlled, and if they do behave not according to the norm, not according to the moral and ethical aspects, that can cause major damage. Now, I'm now moving to the AI in healthcare. With this significant benefits of AI systems and its widespread application across, AI has been used in diagnostic treatment, personalized medicine, drug development, patient monitoring care, and other medical practices. So this is one of the area which human will significantly benefit from their healthcare, but there's a lot of cautions will be needed, because one mistake can cause death and many other issues. So radiologists using machine learning to diagnose X-rays from patients with lung diseases. Now, this is one of the very good applications, because AI machine learnings are very good in image pattern recognition. They are being developed. There are a number of tools big companies has produced which can do a very good job in image recognition. I'll talk about that. The image recognition, if the image is not modified, perturbed, or so that we'll see in the, so predictive modeling to label patients at risk, and in drug development, you can see a number of applications. So global AI in healthcare market size projected to reach 194.4 billion by 2030. So, and healthcares have wide variety of application domains. You can see lab test result analysis. Then imaging is a very successful application in imaging. Then medical device data. So how you collect the user's medical data, healthcare, pressure, sugar level, and all kinds of things. And now there is a federated learning. You can connect all this information locally, then the globally aggregated. So that gives that opportunity to use federated learning, and then clinicians note, analyze patients' wellness diaries, and all other applications. Genomic project in gene sequencing is also being used, AI being used. So recently, the retinal check devices have been which are AI driven, been approved by FDA or use. While these are all good and promising, but study shows, April 20 report, that AI medical devices are not adequately evaluated, and that poses risk. And these are different, mostly the image processing problems, chest X-rays, and all different applications. And these are studies shows that which were lacked in evaluating. So that's a major concern. They need to be thoroughly evaluated and address any biasness or weakness in the system. Looking at different aspects, different applications, this slide summarizes AI/ML bias in different domains. So in healthcare, unequal access and resource allocation may cause some biasness, discriminatory healthcare process, or biased clinical decision making. That's in healthcare. Then in other areas of biasness, lack of representation data sets, pattern biasness, or in design, you can also have different biasness can come in. And then in the judicial system, right, it can cause wrong decisions and make wrong, output, and innocent people can get suffered. So using AI/ML, again, it is not AI/MLs are not magic. It is computational logic. That's the term I always use. So use it not as a black box, use it as a white box or gray box, at least understand how the parameters are being used. Now I'm moving to the another area which is highly promising, will change our society in a big way. It's called digital twin. Digital twin is a dynamic informational model that represents the real world. And it has been used in many different areas: personalized learning, 3D design, supermarket navigation, and list goes on. So it is emulating the real world object. One of the area that in industry, like this is the actual motor, and that's its digital twin. So you can change the design, the way for improvement, or all kinds of things that can be translated. Nowadays 3D printers and others produce much more efficient. So that's the virtual manifestation of a process, environmental condition, and or protocol capable of serving as a known good signal. So digital twins, again, because here is a design optimization and efficiency. So AI based systems are playing important role that to improve that process. And there are many applications of digital twin. You can see augmented reality was introduced by Boeing researchers. Then Google Glass came. Pebbles in 2015 enabled people to see their own hands while wearing virtual reality handsets. And array, so these were gradually progressing. Now with the AI/ML, this has been significantly enhanced. Rosnai is a company which launched Vera, which can create intelligent twin buildings. So you can navigate through the building or the entire architecture using virtual apps. Other reality, the other companies you can see, Microsoft, HoloLens, and all others are coming up with their own virtual reality or digital twin components. Starting from augmented reality, 6 degrees of freedom, capturing 6 directions: up, down, forward, backward, left, right. The people are working as a digital twin who will determine your decision, how you will be influenced or controlled by those digital twins. In medical field, again, digital twin are being used for virtual organs, genomic medicine, personal health information. So basically you see it first and then you produce it, and then you redefine it and go back to the design and development. They are not free from attacks. So digital twin systems are, most of the cases, they are cyber connected. If they are cyber connected, all the cyber related attacks can contaminate, can change the decision, disrupt, breach, and all kinds of things. So this is the physical twin which is doing that stuff. So with manipulation of this process through the cyber-enabled mechanism, whether with a good intent or bad intent or benign way, it can cause damage. So best thing is to use kind of concept of red team and blue team to make sure that the device that will be produced by this digital twin concept has free from all the in other words, it is a good AI application, not a bad one. So then I'm moving to this bad one, the adversarial attacks. On adversarial attacks in machine learning is another growing area of concern because manipulation of training data and model that can cause disruption. In this example, you can see, and it can happen to the image, it can happen to audio. So stop sign with adding little noise, it gives something else that shows the system will understand as green light. Again, Tabbycat, 88%, if you add some random noise, that will show something different. And this is just a very basic one, but things are changing with significantly. Again, with the audio, adding some very small noise, ring that open the door with noise or close the door, it will open the door. So adding the noise, the decision will produce different. So it is not only in audio, image, even in video case, also adversarial attacks are happening. You can see some news, AI-powered cyber attacks, cybersecurity challenges, uptake the artificial intelligence in autonomous driving. You can see hackers are on the brink of launching a wave of AI attacks. And these are some reported vulnerabilities of AI/ML systems in National Vulnerability Database. So any business, they have to consider that there may be an adversarial aspect and how to defend on those adversarial aspects. And there are defense techniques now coming up, but they have some limitations. There are some taking care of the input data entries, some taking over the model. And we developed this, and which also have a patent under submission, where we used a library of filters, input filters, and this library are dynamically changed based on the problem and the decision making. And then also there is an output set of output filters, and they are complement to each other, not the identical way input filters, the way input filters are used and the way output filters are used. And if some results are dropped, they will be analyzed, and there is also a communication between the input and output to make sure the decisions are accurate. So that we tested on a number of data set, benchmark data sets, and it looks like this. So if the input is different inputs coming to the system, and the adaptive filters will select a set of filters. If the filter thinks that there is a noise or manipulation of data, that will be dropped. Otherwise, it will go to any model, any AI/ML model, and that after passing that, then it will go to the output or negative filter. And again, if someone manipulated the model, then it will drop. Or if some filters could not detect some abnormalities or manipulation, if everything is okay, then whatever input coming, that is classified by that. So you can see the idea is to have a correct classification, and then if something drops, that they will be forensically analyzed, making it a closed loop system. in the how I'm doing with my time. Is anybody in the
Yeah, you have 15 minutes.
Okay, so I'll finish a little early and expecting some questions. So the adversarial machine learning is being used with data manipulation or the model manipulation. Now that thing become automatized nowadays using a technique called generative adversarial network, GAN. And here you can see the real data. So, and that's the line we use, the training and produce. But then the input, there is a generator which is slightly variable and fake data, and that's kind of changing the decision of the discriminator slowly over the time, so that it can make wrong decisions. So this is one of the top research areas in machine learning from the adversarial side. Of course, it can also use for positive purposes, for testing the system, how good the system is, that the system is secure, and in all aspects of any cyber systems, they are all dual purpose. So how it will be used and is depend on whether it's a good AI or bad AI or good implementation of it. So here is an example of, this is the normal training and discriminator network, which will determine the classification, whether the fighter plane is a foe or friend, that classification data. But with added noise, a enemy plane may be entered and determined as also a friendly friend. This is an illustration that these kind of things are not difficult. It is possible, and the decision support system, in particularly the convolutional neural network or any deep neural network, studies after studies shows that this is possible. And not only that, there are many other applications of GAN. Like dual GAN is widely used in old days. There are apps last 10-15 years that which can manipulate the images, and even any image enhancing software. You can make the person darker, more brighter, color change, all this. Now most of the phones, smartphones and cameras have that ability. But GAN move it a step ahead. Like here, zebras, you can transfer it to look horse, or horse to zebra. So image to image translation is a class of vision and graphics problems where the goal is to learn the mapping between an input image and the output image using a training set of aligned image pair. So now, if you look at the two generators using the one kind of input, and then you can change the, in this case, change the feature, a man now changed to woman, and there is a large number of examples and how it can be done. In this case, two generators work against each other to determine the real change to fake and support each other, enhancing each other, as this one. And this kind of image manipulation is becoming a concern in social media. Here, in this, again, you can see reported on 14 February 2022, the fake faces created by AI look more trustworthy than real people. It seems that none of these people exist, but this is called generative AI, using again GANs to learn, create fake images that are less and less distinguishable from real image by putting two neural networks that is against each other, the dual gain. So this is where the people's decision making in most of the time now we go to the real, social media, news media. So it comes to the question of fake digital media and role of AI ML. And one of the professor in UC Berkeley, he said once the line between truth and fake is eroded, everything will become fake. We are not able to believe anything. So you can see anyone with a smartphone can now make deepfake, that is manipulation of the face. Initially it was for fun, entertainment, now it becomes reality. We are not ready for what happens next. Fake porn videos are being weaponized to harass, humiliate women. So everybody is a potential target. Now, a new wave of AI-powered art and animation tools, for Dream, Night Cafe, and all others, Midjourney, Delhi, produce realistic images and videos that can cause a range of harms, such as reinforcing racial, gender, and stereotype, plagiarizing artists whose art was, without all these things. And I'll give you one example, very recent one, that this wave of things, yes, it is a technological advance, but how we'll use it. So it seems many of the social norms are changing. Here, you can see I can now create any image in seconds, bringing wonder and danger. So all these they are not real. And they are not real. They are AI generated. So even if you can see these bill papers and the carpet, they are generated, and there are many cases things are generated, but they are generated from pieces which combines together to produce totally new. And here is recently there was a competition, and Jason Allen's AI generated art won the first prize in Colorado State Fair competition. So he generated many of these which are AI generated. And the question comes, is it a cheating or is it plagiarism? Because he did not do anything. It was the AI algorithm or AI system, those are listed earlier, produced those. So that's created a real dilemma for human to manipulate. This is another one using generative AI. Now you don't even have to draw something or some images, text to video creating system. So Meta unveiled the 5 seconds of videos. So you have to tell what it's tell. A dog wearing a superhero outfit with a red cap flying through the sky. And the system in a second will produce something, and that's the picture. So it is not only from text to image, but text to videos are also possible to produce. And Penaki is one of the tools. The paper is submitted for a ICLR conference, and you can see the details of that. And they produce many of those, creative videos. Now it can be used for advertisement, it can be used for movie making, and also it can be used for bad purposes. So the question now comes, the trust in AI systems. How do we trust whether the AI system is, not breakable or have some vulnerabilities, or the system do what is said or what is supposed to do. So the NIST, National Institute of Science and Technology here in US, they listed 9 factors that contribute to human potential trust in an AI system. So a person may weigh 9 factors differently depending on both the risk itself and risk involved in trusting the AI decisions. For example, 2 different AI programs, a music selection algorithm and an AI that assists cancer diagnosis, may score the same in all 9 criteria. User, however, may be inclined to trust the music system selection algorithm, but not the medical assistance. So they did some survey and they came up, this is the music selection algorithm, which is low risk application, and medical diagnosis, which is a high risk application of AI. So even though this 9 parameter, accuracy, reliability, resilience, objectivity, security, explainability, safety, accountability, and all these 9 areas, they are scored almost equal. The blue is the medical and red is the music, almost equally scored. But for user decision, they may trust because this is a low risk, but they may not trust this one because it's a high risk application. And that should be a important judgment factor, even though all the measurements are correct, all statistical results, but how you judge it should involve different factors. Recently, there is a paper published towards verified artificial intelligence where they suggested that at these areas with 15 corresponding elements need to be checked when building trustworthy environment modeling, formal specification, model learning system, scalable formal engine, and correct by construction design. So these are different approaches: probabilistic, active, data-driven, and introspective. In all cases, these things and different colors indicates the dependency on each of those. Representation is one of the important things to make quantitative semantic analysis and other aspects. MITRE Corporation, one of the US organization, suggested 7 connected elements of trustworthy AI: transparent, AI should be transparent, traceable, how that is implemented, AI code and results, safe and secure, how AI protect external, physical, and all other aspects. Then responsible, and who will be responsible if an autonomous system were badly or something went wrong. So that accountability and responsibility are important. Fair and equitable, that's for avoid the biasness. Explainable and interpretable AI is another frontier in AI research, and that may eliminate some of the biasness in AI application. Then the AI should be reliable and robust. NIST is developing a platform for risk management. It's called AI Risk Management Platform, intended for voluntary use to improve the ability to incorporate trustworthy consideration into the design, development, and every aspect. There's a new bill came, and subsequently it has been updated, called Algorithmic Accountability Act. So US lawmakers introduced to protect from bias algorithms, defect, and other bad AI. And you can see there are many sub areas of that. European Union also introducing people need to be informed when they are in contact with an algorithm, not another human being. Any decision made by algorithm must be verifiable and explained. So you can see, and the new very recent guidelines came from United Nations, UNESCO, democratic values. So they asked all the countries to follow national policy for AI, and countries ensure the public participation in AI policymaking and independent oversight. And these are common in every aspect: fairness, accountability, and transparency. AI system for public service. So the recommendation that face recognition should not be used for mass surveillance, and also curtail the deployment of lethal autonomous weapons. So in summary, AI is a powerful tool for a wide variety of applications in pattern recognition, among others. AI challenges dealing with bias, unknown, uncertain, unpredictable, adversarial manipulations. AI is a double-edged technology and can play multiple roles: defensive, offensive, and can be judge, jury, and executioner in a decision-making. AI manipulated and synthesized media can spread misinformation and cause real damage to humanity. AI should be explainable, interpretable, and be used with full disclosure, transparency, accountability, and auditability. Fighting fake media and disinformation is a collective effort involving academia, social platform, government agencies, media, and online users. Enabling ethical and equitable AI requires comprehensive approach around the technology, process, system, data, and algorithms. All AI techniques' impacts on human are far-reaching. Industry leaders need to use ethical AI for greater good. This presentation is based on my technical report, which I did not publish, AI versus AI in Viewpoints. There are few references, but credit should go to all the original contributors of this paper. Thank you, and looking for questions.
Thank you. Yeah. Thank you very much, Professor Dasgupta. Is there any question? If you have any question, you can just type in the question box. No question yet. So let me ask you some question then. What do you think about the AI in the future then? So is this going to be good for us, or is it going to be bad for us? Or
so as our society, there are good things, there are bad things. So similarly, many of the decisions will be handed over to the AI-based systems, but there are, if the governments and society are careful in all this use, have some consequences, and then we may have a better use of AI and better future. As you can see, all the different generative AI concepts coming, creative new things, have a tremendous potential to open new frontier in our thought process. But if it used for faking the reality, picture speaks 1,000 words if it is true or original, but it can give wrong message if they are manipulated. So the purpose and its use play a significant role where the AI will stand. I personally feel in medical field, AI can contribute significantly in human health and human betterment.
Yeah, agree. Okay, I think we use up all the time. So if anybody has any question to Professor Dasgupta, you can send him an email later. And the video of this presentation is going to be posted later on the CAS website or CAS YouTube channel. Okay, thank you so much, Professor Dasgupta, for a wonderful speech, wonderful talk. And thank you so much for coming, everyone.
Thank you for inviting me, and I'm looking forward to any comments.
Okay. Thank you. Goodbye. Good night, everyone. So just